This video lesson will help you find the domain of a function. Remember that the definition of domain is the set of all possible inputs for that function. Consider, for example, the function f of x equals x to the third. You can cube any number, including 0, so any number can go in there for x. So we say that the domain of this function would be all real numbers, and in interval notation, we would write that as negative infinity to infinity. But over here I have g of x, which is the fraction 4 over x. It's a rational function, and we are not allowed to have 0 in the denominator of fractions. So here I would say that x cannot be 0. It can be any other number, but not 0. So to say that in interval notation for that domain, we'll say negative infinity up to 0, not 0 though, and then 0 up to positive infinity. That u is a union, which means that we have all the negative numbers here on the left, all the positive numbers on the right, but not 0. We're excluding the number 0 as showed by that curved bracket. If we wanted to include a number, we would have a square bracket around that number. For example, this domain here, that domain includes the 0 on the left because of the square bracket. Now, common reasons to restrict the domain would be because of those fraction cases where denominators cannot be 0, but also look out for square root expressions because we can't have any negative radicands in square roots, in even roots. Here are a couple examples. Take a look at the first one, 3y divided by y plus 5. It's a rational expression, and I know that the denominator of a fraction cannot equal 0. So what I'm looking for is the number that would go in there for y as an input and give me a 0 in the denominator. Y plus 5, I know cannot be 0, which means that y cannot equal negative 5. I found my domain restriction. In interval notation, I would say this: the domain of that function is all real numbers except for negative 5. The next example over is the expression 1 minus 2x squared. It's a quadratic function, and we are allowed to square any number. There's no fraction in this problem. I have no square root. So here, the domain would be all real numbers, negative infinity to infinity. Sometimes we see a capital bold-faced letter R to represent all real numbers. And then finally, I have the square root of x plus 5. So the expression in the radical here is called the radicand. And then again, R-A-D-I-C-A-N-D, the radicand. And in a square root, we want to make sure that the radicand is always positive or 0. It can be 0, but it can't be negative. So let's take the x plus 5, and we're going to force it to be greater than or equal to 0. Solving for x in this inequality would give me the inequality x is greater than or equal to negative 5. Remember that x is allowed to be negative 5. If x was negative 5, I would have a 0 in the radical, and you can take the square root of 0, which is simply 0. And then every number higher than negative 5 would also be okay. So here's a domain that has a closed bracket because we can include that negative 5. So two reasons to restrict the domain of a function. Watch out for denominators, where we would have to look out for 0s, and then watch out for square roots, where we'd want to force that radicand to remain positive or 0 itself.